Given question: block weighing 6 kN is being raised slightly by means of two wedges with applied force P as shown in the diagram. The angle between the contacting surfaces of the wedge is 5 degree. The coefficient of friction is 0.3 for all contacting surfaces. Find out the value of P required to impede upward motion of the block. Neglect weight of the wedges.
Let us understand given question with the help of diagram. We have to find out applied force P on the wedge where the one surface of wedge is in contact with other wedge and the other surface is in contact with block with weight 6 Newton. Both surfaces of the wedge are inclined and these surfaces making an angle equal to 5 degree with the horizontal lines. We have to first decide the motion for the wedge as well as for the block. Wedge will move in the same direction of the applied force P. So we will show here the motion of the wedge is towards the right hand side. Now the wedge is in contact with block. So as wedge will move towards the right hand side, the block will move in the upward direction. So we have to show the motion of the block. Now we will draw the free body diagram. So first we will decide the wedge. So we have to show applied force P which is mentioned in the question as it is. The motion of wedge is towards the right hand side. So frictional force will act in the opposite direction of the motion. Now we will give this suffix for the contact surfaces. So for this lower surface which is in contact with other wedge, we will give here suffix 1. For the upper surface which is in contact with block, we will give here suffix 2. And for the block which is in contact with vertical fixed surface, we will give here suffix 3. Now we will show the frictional force. So frictional force for the lower surface as well as for the upper surface we have to show in the opposite direction of the motion. This frictional force will be parallel to the inclined surface. So here is frictional force F1 and here for the upper surface we have to show frictional force F2. Now we have to show normal reaction. Normal reaction will be always perpendicular to the inclined surface. So we will show here normal reaction as a N1 and here normal reaction as a N2. Now if we observe P is in the horizontal direction. So we will resolve these forces F1, F2 as well as N1, N2 into two components, horizontal component and vertical component. So we will first resolve F1, horizontal component and vertical component. We will show direction also. N1, horizontal component and vertical component. Then here also F2, horizontal component and vertical component, and then N2 vertical component here and this is the horizontal component. Now how to decide the angle? Now if we observe these inclined surfaces making an angle with 5 degree. So if we observe this F1 and F2 both are parallel to this inclined surface and both inclined surface making an angle 5 degree with horizontal. So this is the horizontal component. So here also angle equal to 5 degree. Now for N2 is perpendicular to this inclined surface and the vertical component is perpendicular to the horizontal line. So both perpendicular lines making the same angle that is equal to 5 degree. So here angle is 5 degree and here also for N1 with vertical component angle is equal to 5 degree. Now it is easy for us to decide the values. Now here we can say for this horizontal component F2 cos phi Then here F2 sin phi. For here N2 cos phi. And here N2 sin phi. In the same way here F1 cos phi. And here N1 cos phi. So near component nearby to angle we have to always mention as a cos term, and component away from angle we have to always mention as a sin term. Now we will move to the free body diagram of the block. So weight always acts in vertically downward direction. So we have to show 6 Newton as a vertically downward direction. Now the surface which is in contact with wedge, we have to show frictional force as well as normal reaction. So the frictional force will be in the opposite direction of the F2, because here we have to use suffix 2. Magnitude is same but direction is opposite. So we have to show F2 is in the opposite direction, and it is also parallel to the inclined surface. Now we have to show normal reaction. So normal reaction will be perpendicular to the inclined surface, and that is N2. Then for this surface which is in contact with vertical fixed surface, we have to show frictional force. So motion is in the upward direction, so frictional force will be in the downward direction. And here we have to show force F3 because suffix is 3, and normal reaction we have to show N3. Now we have to also resolve this F2 and N2. So I will resolve N2 horizontal component, vertical component. F2 horizontal component, vertical component. Now again we have to decide the angle. So we know that this inclined surface making an angle of 5 degree with horizontal. So F2 is parallel to this inclined surface. So we have to show here angle equal to 5 degree. Now N2 is perpendicular to inclined surface, and this vertical component is perpendicular to the horizontal line. So here also same angle 5 degree. Now it is easy to decide the values. N2 cos of phi, and here F2 cos of phi. For this horizontal component we have to write F2 cos of phi. Now how to decide the value of P? So to decide the value of P, we have to first find out this F2 as well as N2. So how to find out F2 and N2? So from the block, if we observe, this F2 and N2 both are common for the block as well as for the wedge. So we will first resolve this block, or we will consider the equilibrium of block, then we will find out the value of F2 as well as N2, and then we will use these values and we will find out the value of P. Coefficient of friction mu is equal to 0.3 mentioned in the question. We will consider the equilibrium of block, and summation of all vertical forces is equal to 0. So we will take F2 sin of phi, then minus N2 cos phi plus F3 plus 6 is equal to 0. That is, for downward direction we have to take the positive sign. Now we will put the value. So what is the value of F2? That is mu into N2. So value of mu is 0.3, and sin of phi, that is 0.087, into N2 minus N2 cos of phi. So cos phi is 0.99 N2 plus, now instead of F3 we will put mu into N3, that is 0.3 into N3 is equal to minus 6. So we will again simplify this. So when we simplify this, then we have to take N2 as a common term, and then here 0.3 N3 term is there, and then minus 6. So here minus 0.96 N2 plus 0.3 N3 is equal to minus 6. So this is the equation number 1 in terms of N2 and N3. Now our aim is we have to find out N2 because N2 is related to this wedge. Now we will move summation of all horizontal forces is equal to 0. So here N3 minus N2 sin phi, then minus F2 cos phi is equal to 0. So again we will simplify this. So instead of F2 we will put mu into N2, that is 0.3 into N2 and into cos of phi. So here when we simplify, then we will take here n2 as a common term. N3 minus 0.38 N2 is equal to 0. So if we observe, this is the equation number 2 in terms of N2 and N3. Now when we relate the equation number 1 and 2, we have to cancel N3. Now here N3 is having coefficient 0.3, so it is plus 0.3. So we will multiply here with minus 0.3 for this whole equation. So I will write here minus 0.3 with this whole equation. Then it will become minus 0.3 N3 plus 0.117 N2 is equal to 0. So this is the equation number 3. Now when we add this equation number 1 and equation number 3, then this 0.3 N3 and minus 0.3 N3 is getting cancelled. And it is easy to find out N2. So N2 is equal to 7.14 Newton. So N2, from this N2 we can calculate F2, that is mu into N2, that is 0.3 into 7.14, that is equal to 2.14 Newton. Now we will use this value of F2 and N2 in this equilibrium for the wedge, and we will find out the value of P. Now we will consider equilibrium of the wedge. So we will take summation of all horizontal forces is equal to 0. So we will take N2 sin of phi plus F2 cos phi plus F1 cos phi plus N1 sin phi minus P is equal to 0. Now we will simplify this. So N2 value we have calculated 7.14. So sin phi into 7.14, that is 0.62, plus F2 also calculated 2.14 into cos phi, that is 2.13, plus F1 that is mu into N1, that is 0.3 into cos phi, that is 0.29 N1 plus N1 sin phi, that is 0.087 N1 is equal to P. So we will transfer this P term to the right hand side. Again we will simplify this, then we will get 2.75 plus 0.377 N1 is equal to P. Now we will take summation of all vertical forces is equal to 0. So from diagram we will write N2 cos phi minus F2 sin phi, then here plus F1 sin phi, then minus N1 cos phi is equal to 0. So value of F2 and N2 is known. So 7.11 minus 0.18 plus now sin phi 0.026 into 0.3, because we have to convert this F1 into N1, that is 0.3 into N1 minus 0.99 N1 is equal to 0. So again we will simplify this. 6.93 minus 0.96 N1 is equal to 0, and therefore N1 is 7.21 Newton. Now we will put the value of N1 in this equation number 3. So we will take this as a equation number 3, or we will take here equation number 4, that is the next equation. And then we will calculate the value of P, that is 5.47 Newton.